So we're now going to write our first quick program for the PSOC here. It's going to be a very easy program to write. We're not going to do very much to it. We'll do a couple variations on the theme of this here, but basically our goal is going to be to create a blinking light. Now I've reduced the resolution on my screen a little bit here because I was running 4K and I just basically storing a bunch of needless information that I don't need. So I'm going to close the PSOC programmer. And then PSOC, if I could actually spell it correctly, PSOC Creator 4.2. So I'm going to launch that, and so it pops up like this. And so this is a software package put out by Cypress. It is free. You can download it and install it on your own computer. You have to like register, but I mean that's not a big deal. And this is not uncommon for companies to release software packages for free that are used on their chips because Cypress is interested in us buying their microprocessors and other things like that, and so that's where they're making their money. And well, they're giving us tools that we can then use to program them, so we don't have to go out and find our own set of tools that will then interface with their chip to program them. So let's go ahead and get going here on writing our first program here. So this is going to be the set of steps. I'm going to go through this relatively slowly this first time, but this set of steps that we're going to do here is what you're going to need to do every single time you create a project for your PSOC. So I'm going to first do new project. And now, first off, we have to select the target device. Yours might have target module listed. And the problem is it's like, okay, well, which one of these is the correct one? Target device, now it says last used, which you can use that typically when you are using this like multiple times. Like if you create a project and then do some code and then you create a new one without changing the computer or logging it out, it's going to be the same one. But you can always be certain is that you want to make sure, well, PSOC here, there's different families of these chips. And we actually use the PSOC 4 family. And then we use the PSOC 4200, which you actually can probably see on the outside of your little package that you got. So we use the PSOC 4, PSOC 4200, then next. Now, you can do a pre-populated schematic. They also have code examples, which is great if you're wanting to look at how to do some things. Pre-populated basically is creating the APIs for every single thing that's already been connected up to the processor. We will never use the pre-populated one. I don't like it because basically what it does is it creates a lot of APIs that are not necessary and creates a lot of connections that aren't necessary for our program. So we'll always start with empty schematic. And then we have to give it a name, a workspace name. Now, a workspace is different than a project. A workspace, you can have multiple projects within a single workspace. The idea, you think of your workspace as your desk, and you're going to have, multiple documents on that you're reading, or textbooks or homework assignments that you're working on your desk. So we can have multiple projects within a workspace, but we can only have one workspace at a time. So I'm going to call this here. First off, I'm going to change the directory here. Instead of it being on D, I'm just going to go ahead and still save it on my mag drive, but I'm going to put it under work and under my CPE, and then I'll call another folder here, and I'll say these are examples. And so I'm going to select that folder here, and it does remember this. Like if I close out of this program, it should go there. Instead of calling this workspace 1, I'm going to just call this here blinking LEDs, and I'm going to call design 1 the blink 1 because we're going to make a blinking LED, and this is our first way we're going to do it. All right, then we click on the finish button, and it's going to generate a lot of stuff over here. Now, again, this First one, we're going to go through this really slowly here, but this right here is what's called our top design, and it almost looks like a circuit designer here, and it's going to be very similar. And these are our component catalogs. So basically what it's saying is that there's a lot of things that we are typically going to be using here, and this lets us kind of just drag and drop some things so we can get the proper APIs, which stand for Application Program Interface, created. And then there's other things here we'll see as well. But you can kind of look over here. If you go under analog, there's, analog to digital conversion, digital analog conversion, all sorts of other stuff as well. You can actually do logic gates on here. You can put a logic gates and do logic gates and all sorts of stuff like that on this. But one of the things we'll be using a lot here are the ports and pins. And that's what we're going to need actually for our very first one anyway. So let's go ahead and look at the ports and pins here. We have an analog pin, which we will use, but that's again if you're inputting analog data. You got bidirectional, so that would be obviously an input and an output pin, so you could use it both as input and output. Then you have digital input pin, obviously that's only for an input, and then digital output pin. So for this one, we're going to need a digital output. So I'm going to just left click and drag this onto here, and Control Zoom lets me zoom in a little bit here. And then I'm going to double click on this here because I need to set some properties on this. First off, before I set any properties, whenever you double click on one of these things, I want to show you a very important little function here, feature, is this data sheet here. So we can click on this data sheet and it brings up the data sheet for this particular component. Now, it's not just the digital output pin. This is in general for all pins. So if you read through this, there's a lot to read. There's a lot of different ways to do this, but it's got the analog, the digital input, digital output, all sorts of the digital bidirectional. But one of the things that's always important in these data sheets, there's a lot of things, but notice here there's this application program interface, this API. If you click on that, you can go down and, here, let me zoom in on this even a little bit. That's a little too much. We can see here that we've got what are called some general APIs, and you can see here it's got a function prototype, unsigned int 8, which is an unsigned integer, 8 bits, pin read. You can kind of figure out what it's going to do. It's reading the state of the pin, and it takes nothing in as a value. It's a void function. You don't need to give it any input. You're just going to read the pin, and it's going to return what the value of the pin is. And then here is a void pin write, which is going to have us, of course, write a value. Now, there's no value returned, but of course we can see here we need to put unsigned int 8 in there. So it needs some value here, unsigned integer, in order to write. Now, if you click on one of these, it's going to actually take you to the actual thing where it gives you more details and kind of even gives you how to use it as far as a sample little bit of code here. And then, here's even the pin write. It's showing you how to even do this here as well, as far as writing this for the pins here. All right, so that's what we have here, but we should give this a little bit more meaning than just pin 1. So what we're going to do is we're going to call this B LED, because we're going to connect this to the blue LED on our device here. Now, one thing here is that sometimes we will use a hardware connection, but currently we don't need a hardware. That's what HW stands for. It's not homework. Hardware, or hardwire, is really what it stands for. We don't need that connection. And then notice there's an initial state. We can have it be either initial low or high. And then we're going to click on OK. Now that gets the pin set up. I should show you one other thing here. The drive mode. There is a lot of different drive modes here. And we will change this depending on whether it's an input or an output pane, but strong drive is what we want for an LED. So now that's the only component we're going to use, because as I said, all we're going to do is get the LED to blink. So we don't have any other components at this point yet. When we get to more complicated programs, the top design will have maybe like a dozen or so components or even more on it in order for us to write our code to do everything. Now, before we can actually start even writing some code, we need to go here to pins, because you can see here it's got named BLED. And so we have to tell it where the blue LED is. Now you can see here, we've got a bunch of different pins here, and some of them are already assigned. Like this is the actual chip that is on our board. That's the Cortex-ARM M0 processor. And there are some things that we can't assign for. Obviously there's power here, and ground is the VSSA. We can't actually obviously assign anything to those. But the pins that we can use, the GPIOs, are all of these pins here. And this stands for port 0 pin 0, port 0 pin 1, port 0 pin 2, port 0 pin 3, so on and so on. And so this would be port 2 pin 7 over here. Now, we can't just automatically just randomly put this pin wherever we want. The reason is because this pin, we're using the onboard LED. Now, if we were manually soldering a blue LED into this device on our own, we absolutely could attach it to any of the GPIO pins. But since we're using the onboard LED, we have to use the one that it's already been attached to. And if you look on it on your board here, it's actually somewhat difficult to see, but if you look up by your thing here, we'll see there'll be a G and a B, and there'll be an R even. And if you look carefully, the B is port 0 pin 3. That actually means that the blue LED has been wired to port 0 pin 3 of our PSOC device. And so what I did is I just left clicked and dragged this over and said, okay, that's on port 27 there. And so then that now configures our processor so that we can generate an API and it knows where the pin is. I'm going to actually stop this video because I'm sure it's getting a little long here, and I like to make them not too long.